Hello, fourth graders. We are going to continue to learn about electricity today, and we're going to be studying conductors and insulators. And so last week, you learned how to build a circuit, and you learned what a closed circuit is. A closed circuit is a circuit that has no gaps in it. The electricity and electrons can flow through it, and it will work. And an open circuit is when the lights are off because there's a gap in the circuit, and the electricity can't flow. Today, we're going to learn about two different materials. Conductors are materials that allow electrons and therefore electricity to pass through it. And if you put a conductor into a circuit like what we built last week, the light bulb will light because the conductor lets the electricity flow through it. An insulator is a material that does not allow electrons and therefore electricity to pass through it. And so if you add an insulator to an electric circuit, like the ones that we were making last week, the light bulb will not light because the electricity cannot move through that circuit. And we're going to look at what types of materials are conductors and what types of materials are insulators. The first thing I want you to watch is this Zoom video. It's about the lemon battery. And it starts to introduce you to the idea of what a conductor is, something that allows electricity to pass through it. All right, so I'm opening up that video for you. And here we go.
Lemon battery experiment, we discovered that electricity could pass through our bodies. What if we go like this? Oh yeah, it works! This is so cool! The electrons are throwing through both of us and going into the clock. Oh my gosh, so... Well, Natalie emailed us this challenge to see how many people we can have the electrons go through and still have the clock on. Mike, do you want to come out and help me with this? Alright. So, we know that if we disconnect any part of the circuit, it's not going to work. Mm-hmm. What if we cut it? Oh, cut the lemon? Yeah, cut the lemon. Alright, try that. So, right when I cut it, it's going to disconnect as soon as the two lemons come apart. Yeah. Here, try holding the two lemons. Does it? That's so cool. It's because the electrons go through my arm and then back down the other one to complete the circuit. Hey, wait a minute. Why don't you hold this one? If I hold this one. Does it go off? It goes right off. So when we hold hands, it turns back on. It turns back on. So want to try? That's so cool. People? Yeah, sure. Alini, do you want to come out and help us? Sure. So the circuit is disconnected. So the circuit's disconnected. You have to come between us. And so if we hold hands, it might... Is it working? Yeah, it's still working. So cool. Estuardo, do you want to come on out and help us? All right. So there's 4 people. And it still works. That's so cool. That sounds awesome. Hold on really tight, guys. Come on, Courtney. Guys, why don't we I didn't think that was going to work because I thought the resistance, like the flow of electrons was going to... Well, I guess because we're like all connected. Yeah. Because the mic is on. Yeah. It's off. It's on. It's out. You guys want to try it with the voltmeter now? Sure. Do you want to test it out first? Yeah, let's try it with the lemons first. So let's see how many up there. So that's 16 millivolts. Now let's try connecting hands. So it's 4 or 5. 4 or 5. What do you think's gonna happen if we add more people? I think there's gonna be a definite decrease. Yeah, me too. The more people there are, the more resistance there's going to be from body to body. And I think this is definitely gonna be decreased. All right, Caroline, do you want to come on up? So you'll come in the middle. Okay, ready? Wow. Sit in between 3 and 4. Courtney, do you want to come on up? All right. Hey, Courtney. Hey, Courtney. We're testing the voltage. So we got the first 4 and then almost 4 again. Yeah. It's a little bit less, so that's going to sound 3. Alini. Come on, Alini. Oh, jeez. I don't know if it's going to work. Do you guys think it's going to work? I don't think it's going to work. So cool.
Conductors are materials that allow electrons to move through them. The wires of the lemon battery are conductors, and we're conductors. that electrons flow through is called a circuit. When the circuit is connected, the electricity can flow. When the circuit is broken, the electrons can't flow.
So the next time you turn off the light, you can think about the fact that you're disconnecting a circuit. Can somebody please reconnect the circuit? Thanks.
All right, so that's a pretty cool experiment, and I hope it helps you understand what a conductor is and how the circuit has to be closed and touching. Now, some important things to remember about this is that the reason that works is that because that little clock needs so little energy. And so you could never let like the voltage or the power that it would need to light your lights in your house go through your body. That would really hurt you. And so the reason these kinds of experiments work is because we're using such a small amount of electricity. A lot of you sent me questions about that energy ball. You thought it was super cool. And so the energy ball works really similarly to that lemon experiment. So watch and see how we can connect those two together. Okay. So a lot of you sent me questions about how the energy ball works, and it works just like what we just saw in that video about the lemon battery experiment. So what this ball is inside there is a circuit with a light bulb and an energy source and some wires, but it is not a complete circuit right now. It's an open circuit. The way to make it a complete circuit is to have these two metal pieces touch each other. There's a gap in the circuit. And so we just learned that people can actually conduct electrons. The electrons can move through us. So if I put one hand here on this metal piece, it's still open. But if I put my fingers and touch both, the electrons are now going through my thumb, through my hands, back to my finger, and completing the circuit. And that's how it works. So now it's an open circuit, and now it's a closed circuit. And just like with the lemon battery, I could add people, like when you saw me do this experiment with my family, and we could add different people. And as long as we're all connecting and touching each other, the electrons will just keep flowing around in the circle. So when I touch both pieces of metal, I close the circuit, and the electrons can flow through my hand as part of the complete circuit. Okay, so now for today's experiment, we're going to look at some different materials. So the first thing I want you to do is make some predictions about what materials will be conductors that will allow the electricity to flow through it, and which of these materials will be insulators. And so for our testing materials, I've included a metal paperclip that's coated in plastic, a quarter, a penny, a rubber band, an eraser, a hair tie, which is kind of like made of stretchy cloth, and a pencil. And so either you have two choices. You can get a piece of paper and you can write down your predictions, press pause, or you can just do it in your head right now, predicting which ones of these will be conductors and which ones will be insulators. If you need some time to think, you can go ahead and press pause, or if you need some time to record your predictions, you can press pause. All right, so I think you've pressed play again, so that means you've finished your predicting. So now what we're going to do is we're going to test these materials, and we're going to find out which of your predictions were correct and which of your predictions were incorrect. So let's watch this video so you can see the testing. Okay, so now we're going to test those materials that you made a prediction about. And the way that we do that is with what is called a testing circuit. So last week we built a circuit with a battery, a light bulb, and two wires. And when I attached the wires like this, we knew that it was a closed or complete circuit and the light bulb lit. Well, now I added another wire on, and right now the light bulb's off, so we know this is called an open circuit. But if I touch these two pieces together, the light bulb lights, and I close the circuit. Well, I can use this to test my materials by putting the materials into this gap right here. So all the materials that I asked you to predict, we're going to test each one of them. So first we had the paper clip, and you guys predicted this is either a conductor that will allow electrons to pass through it, or it is an insulator. So if I put it here and I touch these two metal pieces of the wire, you can see the electricity is going through the paper clip and the light bulb is lighting. So on your chart, you should check off paperclip is a conductor. The next thing that we were going to test was a coated paperclip. So this is a paperclip. It's metal on the inside, and it's coated with plastic. And you should have made a prediction. Do you think this will allow electricity to flow through it or not? Is it a conductor or is it an insulator? So I put that in my space, and I touch the metal to it, and I see that this is not allowing electricity to pass through it. The light bulb is not lit, so this would be considered an insulator. It blocks the electrons. It doesn't let the electricity flow through. All right, next on my list is the rubber band. What do you think? Are rubber bands conductors or insulators? I put it in my space and touch the metal to it, and my light bulb is not lit. So this also, the rubber band is also an insulator. All right. Oh, I wrote a hair tie, but I meant a hair tie. Okay, so now I have a hair tie, and that's this stretchy material. Put that here. I touch the metal to it, and light bulb doesn't light. That means this is another insulator. Okay, next thing I had was a penny. Did you predict the penny would be a conductor or an insulator? Put this here. Touch this to it. And surprise, surprise, a penny is a conductor. Now, how many of you predicted that? A lot of you probably remembered an experiment we did in 3rd grade, and I wish I had a magnet here right now to show you, but you learned last year that pennies are not magnetic. And so a lot of you, because it's not magnetic, were probably thinking it wouldn't conduct electricity, but we just proved that it does. So that would be a conductor. Next is the eraser. So you probably made a prediction about the eraser. Conductor or insulator. Put that here. Touch my metal to it, and the light bulb is not lit, so that is an insulator. And then I have a quarter. Again, what's your prediction? Conductor or insulator? Put it there. I touch the metal, and you can see it is lighting the light bulb, and this is another conductor. And my last one is my pencil. Now, if you guys were at school, you would definitely be testing your pencil, and you'll know there's some different parts of the pencil you can test. So first I'm going to test the wooden part, and you'll see when I test the wooden part of the pencil, is it a conductor or an insulator? It's an insulator. But then a lot of you would say, oh, well, what about that part right here on the pencil? So if I touch the metal to that part, surprisingly, that is not a conductor also. It's also an insulator. Oh, it's touching each other. That's what happened. If I touch the metal to each other, it also lights up. But here, if I'm keeping these two apart and I'm just touching this, it doesn't. And some of these are made of metal, and if it were, it might light up. It will light up this up, but this is made of plastic, so mine didn't work. Okay, so that would be an insulator. So now, if you look at our materials, the paper clip, the penny, and the quarter were conductors. Wood, rubber, plastic, cloth material, these were all insulators. So can you draw a conclusion about, in general, what type of material makes a good conductor? What do all of these have in common? They're all made of metal. And metal is a really good conductor of electricity. Okay, so now that you've done that testing and have finished this video, I'm going to ask you to complete the Google Docs to show me what you have learned about conductors and insulators. So you'll click on those words that say Alicia Sherman posted a new assignment. That's at the top of the Google Classroom posting, and it should open up to a page that looks like this. I want you to type in your name, first name and last name, and your classroom teacher's name. And then there's just 4 questions, just so I get a sense of how much you understood from that video. What is a conductor? Give an example of a material that is a good conductor of electricity. It can be something we tested. It can be a general answer. What is an insulator? So the definition, and then an example of a material that was an insulator in our testing. And once you finish that, you can turn it in to me and you are all done for today. On Wednesday, I have a really cool experiment where you'll get to do some practicing and do some of your own testing. And don't worry, you won't need any materials at home. It's an online simulator, so it'll be a really cool way for you to test out conductors and insulators.